Hello, and welcome to the video presentation of the Swinomish tribe's Bioaccumulative Toxics in Native American Shellfish project. This video will provide a visual depiction of the entire project, from start to finish and all parts in between. Throughout the project, the Swinomish videographer has filmed segments of advisory board meetings, collection of shellfish specimens, environmental education presentations, and many other relevant activities, many of which are compiled here in this video. First, a bit of background about the tribe and the project. The Swinomish Indian Reservation was established on the eastern portion of Fidalgo Island in 1855 by the Treaty of Point Elliott. Fidalgo Island is the gateway to the San Juan Islands in the Puget Sound in western Washington state, and it's located approximately 70 miles north of Seattle. The creation of the reservation brought together the Kikialis, Swinomish, Lower Skagit, and Samish bands. Today there are approximately 1,000 enrolled tribal members. The reservation is 90% surrounded by water, primarily salt water, that sustains a rich marine and intertidal environment. Shellfish found in these tidelands are one of the most commonly collected seafoods and represent a vital subsistence and commercial resource for the tribe, as well as an important point of cultural association for the tribe's identity. Shellfish are employed in cultural ceremonies, incorporated in the common diet, and sold to support families on the reservation. This project was initiated based on published reports from regional and state tribal agencies, citizen watch groups, and previous tribal staff findings. What they found was the presence of persistent bioaccumulative toxic chemicals in local waters and sediment. These toxic chemicals pose a serious threat to culturally, socially, and economically significant subsistence shellfish beds on tribally owned tideland and in usual and accustomed areas. Okay, what does usual and accustomed areas mean? Stevens used this term in several treaties with northwestern U.S. tribes. The term describes lands adjacent to streams, rivers, or shorelines to which a tribe usually traveled for the purpose of fishing, hunting, and gathering. These areas are outside reservation boundaries, but tribes reserve the right to continue to fish, hunt, and gather in these locations. The project hypothesis is that Swinomish people are exposed to low-level, chronic bioaccumulative toxics when participating in subsistence consumption of shellfish. The four specific aims of the project are to 1. Determine whether Swinomish people who harvest and or eat shellfish from the reservation or in usual accustomed areas are exposed to bioaccumulative toxics by testing sediment, clams, and crabs. 2. If health risks are identified, to effectively communicate those risks in a culturally appropriate manner. 3. To develop mitigation measures. And 4. To confirm major health problems on the reservation that may be related to eating contaminated shellfish and develop hypotheses between the health problems and toxics found. To find these out, we assembled a group of key personnel from Swinomish who worked with two advisory groups, a technical advisory group that provided expertise in risk assessment and management, and a tribal advisory group comprised of representatives from Puget Sound area tribes who had similar concerns. Our first step in the project was to determine what we wanted to test for. We chose to analyze 7 heavy metals: arsenic, copper, cadmium, selenium, mercury, lead, and nickel, PCB aerochlors and the Hulis congeners, polycyclic aromatic hydrocarbons, the extended list, dioxins and furans, chlorinated pesticides, and butyltins, organotins, including TBT, the anti-fouling material paint that's found in boat paint. We hypothesized that these chemicals could be entering the local ecosystem from a number of sources, including but not limited to unregulated landfills and leaking underground storage tanks, industrial water effluent from 2 petrochemical facilities located adjacent to the reservation, log yards, marinas, agricultural runoff, both present and historic, wastewater treatment plants, atmospheric deposition from industries in the airshed, such as pulp and paper mills, historic pulp and paper mills, aluminum smelters, other petrochemical facilities, and non-point source pollution such as road runoff, heavy boat traffic, and natural background sources. It was not an objective of this project to specifically determine the origins of these toxics, yet we did test for some toxics that can be used in fingerprinting, such as the extended list of PAHs, should results and mitigation options point to further research into point sources. Next, the sample collection. In early summer of 2002, we collected 16 composite samples of sediment, 16 composite samples of butter clams, and 16 composite samples of native littleneck steamer clams from reservation tidelands and in usual accustomed areas. The following year, in 2003, we collected samples of Dungeness crabs from the local waters. We focused the project on shellfish for a number of reasons. Because there was little data on toxics in shellfish in the area, but research indicated the presence of chemical contamination, because shellfish are important to the tribe and consumed in quantities that may pose health risks to tribal members, and because they are sedentary, in the case of clams, or have a limited roaming radius in the case of crabs, and therefore the results may be useful to fingerprinting contaminant sources in future studies. Of all local shellfish consumed by tribal members, clams and crab were chosen because they represent the most frequently harvested and consumed types of shellfish, because they are locally abundant. There have been previous studies of some crabs and clams in other areas with which to compare our data. Sample sites were chosen based on frequency harvested by tribal members, both presently and historically, the proximity of the area to potential contamination sources, and accessibility. The sample sites are generally grouped in 4 main water bodies: Padilla, Fidalgo, Similk, and Kickit. First, the clams. We sampled the following species. Native little neck clams, also called steamer clams, are hard-shell clams, and they reside in estuaries from Alaska to Mexico. At full growth, they are on average 3 to 4 inches in length. The external surface is marked with concentric rings and radiating ridges, which produce a cross-hatched appearance. The color is variable, but normally cream or gray, and sometimes molted with brown markings. The shells close completely. They are found in the top 4 to 6 inches of substrate in gravel, mud, and protected bays. Normally, this clam is somewhat higher in the tidal zone than butter clams, being concentrated at about mid-tide level, but are sometimes found mixed with butter clams in the lower intertidal and subtidal zones. The butter clams are also hard-shell clams that are found in estuaries from Alaska to California. The shells are large, up to 5 inches in length, heavy, oval to square shaped, and externally marked with concentric rings but no radiating ridges. They are yellow in color when young, aging to a gray-white with age. When disturbed, the clam withdraws completely into the shell, leaving a slight opening between the valves in the area of the siphon or neck. Butter clams are normally buried in the substrate between 8 and 14 inches. They prefer sand gravel beaches and are concentrated in the lower intertidal and shallow subtidal zones. Before any sampling began, extensive preparations took place, including quality assurance and quality control procedures. Our project team followed stringent quality assurance quality control protocols as detailed in our approved Quality Assurance Protection Plan. We chose to follow sampling procedures outlined in the Puget Sound Estuary Program's 1997 publication, Recommended Guidelines for Sampling Marine Sediment, Water Column, and Tissue in the Puget Sound. For the sediment and clam collection events in the first year, we followed common subsistence harvest techniques of collecting clams with pitchforks and storing them in buckets, with the added project twist of the strict adherence to QA/QC decontamination protocols. We used new stainless steel pitchforks and new buckets for the clams, and site-dedicated stainless steel bowls and spoons for the sediment collection in order to minimize contamination during sampling and transport from the field to the Swinomish Environmental Lab. In the field, the crew set up transects running parallel to the water in the tidelands in prime clam habitat during the negative low tides. Each transect line was given a random number, then flags were placed every 50 feet starting at a given random number, dictating where the diggers would dig. Diggers collected only legal-sized clams, which would be greater than 1.5 inches with intact shells, and harvested a total of 60 butter clams and 60 steamer clams from each site. Sampling site coordinates were recorded using a handheld global positioning system, or GPS. Clams were rinsed in situ water, wrapped in new aluminum foil, bagged, labeled, and placed in a cooler with ice for transport to the Swinomish Environmental Lab. Sediment samples, co-located with the clam samples, were collected contemporaneously, homogenized in a dedicated bowl, and placed in glass containers in a cooler with ice for transport to the lab. After 6 days and 15 sample sites plus 1 site duplicate, we ended up with a total of 128 sediment containers and more than 1,800 clam specimens in all. An on-site QA/QC officer looking over our shoulders to make sure we were following protocol and chain of custody paperwork in triplicate. Suffice it to say that we successfully shipped the samples to the lab and ended up with a comprehensive paper trail that filled a very large filing cabinet in our record storage area.